Okay, so here I have the problem from number 3. It is of course a conic. We can tell this by the fact that this is a general format of the conic, and it kind of fits. Negative x squared plus 4y squared minus 8x minus 8y minus 48 is equal to 0. We can also identify that it is a hyperbola. And we can tell this because I have 2 squared terms and they have different signs. There's a negative attached to this x squared and my y squared is pretty positive. And so that's how we can tell that it is a hyperbola. And now that I know that, I can go ahead and complete the square to rewrite it in standard form of a hyperbola. So first thing, I'm going to add that 48 over to my right-hand side to get it out of the way. And then I'm going to take my y's, and I know I have a common factor right away of 4, so I'm going to pull that 4 out. I'm left with y squared minus 2y. I'm going to half that negative 2. I'm going to get a negative 1, square it. I'm going to get a plus 1. And what I do to one side, I have to do to the other. So I can't forget to distribute that 4. I'm going to actually add a plus 4 to this right-hand side. And then I'm going to take my x's. I have a negative x squared and a minus 8x. I'm going to pull that negative out, and I'm left with x squared plus 8x, half it, and square it, and I get a plus 16, but I can't forget to distribute that negative. So I'm going to subtract 16 from my right-hand side. It equals out to 36, but I want a 1 on this right-hand side for the general form of a hyperbola. So I'm going to divide everything by 36. This is what I get. 4 goes into 36 9 times. This really doesn't simplify, and I get 36 divided by itself is, of course, 1. I can right away identify that my center HK is at negative 4, 1. And then for my hyperbola, I know that it is a vertical hyperbola. It's going to open up and down. I can see that by the standard form that I get matches that of the standard form of a vertical hyperbola. I could also see that my x and my horizontal value a is being subtracted from my vertical y value b, whichever way you see it. My transversal axis is going to be vertical, just like my hyperbola, and so it's going to be at x equals negative 4, same value as from our center. Looking at all of this, I can go ahead and find my fundamental rectangle, which is kind of going to help us see where our asymptotes are going to be and where our vertices are going to be. My a value from here, 36, square root it, and I get a plane 6 for my plane A. And if I were to square it, I would get that a squared being 36. Same for the 9, square root it, it's 3. And that's going to help us map this fundamental triangle. So it's really simple. You just go left or right 6 and left 6 for your horizontal value, and up and down 3 for your vertical value. So you can just count over like that. Think of it like a slope almost. Up 3 over 6 or down 3 over 6. Because I have this vertical transversal axis going through my center, I can see that I have my vertices right here at negative 4, 4, if you just count up, and negative 4, negative 2. So that's how I can find my vertices, or if you wanted, you could double check and just count, add that vertical B value to your Y value of your center. Either way will work. But for my focal length, my C, which is the length from the center to the focus, I can get the square root of a squared plus b squared, and I know that that will equal my C. So I can plug in my 36 and my 9, add them together, and I get a 45. And I know that 9 times 5 is equal to 45, so I can kind of break that down. I know that I have the square root of 9 is 3, so I can pull that 3 out. And I get C is equal to plus or minus 3 square root of 5. And so here, that's where my foci are at, negative 4, 1 plus 3 square root 5, and minus. And if I want to get specific, which will be helpful later, I can plug that into a calculator and I get that 3 square root 5 is about 6.7. So I have -4 at 7.7 and -4 at -5.7, and that is my foci. And then before we graph it, I'm going to find the exact equations for my asymptotes. Because if I wanted, I could take this fundamental triangle and my asymptotes, they're going to go through my center and they're going to go out these corners, and I could just kind of draw a quick little line. But to be specific, let's find the equation. So I know that my slope is equal to plus or minus b over a. So I could plug in my b and my a that we found earlier, and it would just be plus or minus 3/6, simplified to plus or minus a half. And I can plug in my y and my x and my y values from my center into this equation here. So let's just take my negative slope. I plugged in my 1 for my y and my -4 for my x, and to find my y-intercept of b. So for the negative slope, I found that my y-intercept for my asymptote is at -1. So the equation for the first asymptote is just y equals -half x minus 1. And for my positive slope, I did the same exact thing and find that my y-intercept for this asymptote is at 3. And so here's my equation for that second asymptote. It's just half x plus 3. I can go ahead and look at my graph, and I can see that my asymptotes do intersect at the the vertical axis at -1 and 3. So that's all correct. And if I wanted to, I could just plug in each x value and find what the y value would be, as you would do with the slope, and I find that those are my asymptotes. Here I have the foci that we found earlier at -4, -5.7, -4, 7.7 for this upwards one. Of course, my vertices that we found down here at -4, -2, and -4, -4. And my transversal axis going through all my foci, vertices, and my center. And here I have my asymptotes that are kind of guiding my hyperbolas. They aren't gonna, they're never gonna cross or intersect, but they're just kind of gonna follow it like a little path. And here's my rectangle that I found. 2a times 2b is also another way you could find it. And then let's check our intercepts for my hyperbola, where this hyperbola exactly intersects. As we can see, this is my x-axis right here, and it never crosses for this one, but it does cross that y-axis. So let's take a look at that. So to find the y-intercepts, I'm going to take that general form of the hyperbola that I found earlier, and I'm just going to plug 0 in for x. And I want to get rid of that 36 right there, so I'm just going to multiply each side by 36. So I get my 4y minus 1 minus 16, because 4 squared is equal to 16, and 36 on my right-hand side. I'm going to subtract out that 4 to get rid of it. Oh, sorry, I added over that 16, so I got 52. Now I'm going to divide it all by 4, and I get 13. I want to get rid of this squared right here, so I'm going to square root it. So I get y minus 1 is equal to plus or minus 13. And then of course I add that that 1 over, and I get y is equal to 1 plus or minus square root of 13. So if I wanted to get a little specific, which is helpful, square root of 13 is equal to about 3.6. So 1 plus 3.6 is about 4.6. And 1 minus 3.6 is about negative 2.6. And so we can check our y-intercepts real quick. Here, if we were to count down, we've got a 1, 2, and not quite 3, so it's about 2.6, so that's good. And then over here, it's 1, 2, 3, 4, and not quite 5, so that's 4.6 that we found. So our intercepts are good. And then by looking at this, we can tell our domain and range. So for our x values, it's all real numbers from negative infinity to positive infinity. Because it's a vertical hyperbola, it's kind of never ending. It just keeps going because it's never going to touch that asymptote or intersect it fully. And for my range, I start here at my top, my positive hyperbola. It starts at 4 and goes upwards to infinity for my y, and for my negative hyperbola, it starts at -2, or my downwards hyperbola, it starts at -2 and it goes into negative infinity. So there you have negative infinity to -2 union with 4 to positive infinity. And that's how you complete the square and graph a hyperbola.